Okay, in this project we're going to take a piece of recycled oak from an old table, or actually an old chair seat, and we're going to create a 3D piece of art and engrave a 3D pattern on it, as well as cut it out on the CNC machine, and we'll look at the bits used and lessons learnt. That's what we should land up with at the end of the day. So let's have a look. Let me take you through the steps that I follow to create this object. The software I'm using is Vectric Aspire. Best practice for when using any type of CAD software is to try and break things into their different layers. So I started off with dimensioning the material and what I wanted to create. I first set up the job. I used the thickness of the material. So the piece of reclaimed wood I used was planed down on both sides on the CNC machine to get it perfectly flat, and it landed up with 17 millimeters of material left, and the piece of material is approximately 445 by 445 mils wide. And I set my XY date and position to be right in the middle of the material. In the dimensioning layer, I created some circles to help me, or to use as a guide in creating this sweep that I drew, and I used the modeling feature over here, this 2-rail sweep, to follow the contour of the sweep all around the circle in order to create the 3D object. And this is, once you finish with the sweep, you are left with 3D object, and that's what the object looks like. So you can actually see the contours of that sweep followed. You zoom in a bit, you can see that it's a nice 3D object. I made sure that when I created it, to ensure that the depth of the material was correct and that we did not get too thin near the bottom of the material in order to weaken the overall structure of the CNC part at the end of the day. Once we had our 3D object created, I then went ahead and I imported a EPS file that I found that has some nice patterns. You could, of course, go ahead and create these yourself, but there's lots of resources available where there are patterns that you can download in EPS format, or any vector format should suffice. And I chose one of the patterns to use. I ended up using this one over here. Let's just zoom in a bit so you can see better. The pattern came with 2 lines offset from each other for each bit of the pattern. So what I did is I just cleaned it up by going down, holding down shift, and just selecting the first line all the way down until I landed up with the pattern I wanted. Let me just zoom in here for you. As you can see, I've cleaned up the lines and I copied it onto a new layer, which is the vector layer. And then I created these little circles, this little circle in the middle. And the way I did that is I just created the circle, I grouped it, I used this offset and layout feature over here, which is to copy object along vector lines, and I copied that object. I used the line over here as the line to copy across, and I copy that object all the way around the circle to create a nice pattern. And that's what I landed up with. Then I went ahead and took this pattern and I told the software that I wanted to carve out this pattern along the surface of the 3D object that was created. So I wanted it to follow the contours of the actual object. I then went into the toolpath area, and let me just show you what I did. I first started out with a roughing end mill. If you have a look, I used a 6mm end mill just to rough out the part, and if we preview that, that's what it looks like. So it hogged out a lot of that material, and then did a 3D finish on the boundary of the object with a 3.1 mil end mill, or 1/8 inch if you are not metric, and I generated the toolpath. This is what it looks like. As you can see, it's very involved. Let's preview that so you can see what it looks like. Take the lines off, and that's what we left with at the end of the day. After that, I projected with a Fluting Toolpath the actual pattern from the vector that we downloaded, and I chose to go down 1.25 mils. I used the same ball nose end mill, so I didn't have to do a tool change, and I chose to project the toolpath onto the 3D model. And let's go have a look there and preview this. There you can see the path that it's going to follow, and that's how it cut it out, or that's how it carved the pattern in. And finally went to the profile toolpath, where I put back in a 6mm end mill, and I used some tabs to hold the part down on the final cutout. And let's have a look at what that looks like. As you can see, went around the whole part, and you can actually see it jumping over the tabs. There's a tab over there, there's another one over there, and if we preview that, that's what we left with. Cuts the material out. Now you can see our tabs all the way around, and those are very easy to clean up at the end and holds the part nice and secure. Before we move on to some video footage of the part actually being cut on the CNC, I just want to show you what you need to be careful of when doing your 3D finishing pass. I'm just going to reset this preview. Very important is in this 3D roughing preview to actually set a boundary offset. What this does is when it does your roughing, it goes a little bit further on the boundary here, so that when you get to your 3D finishing toolpath, which is going to be in orange here, so you can see the distinction, As you see, it's running backwards and forwards, backwards and forwards. If you don't leave a little bit of an extra gap here, an offset, as you can see by this green over here. So if we zoom in here, you'll see that as the tool comes backwards and forwards. So I will just undo the last and I will slow this down a little bit. You'll see as the tool's coming backwards and forwards there, if you do not have that allowance in, that tool is going to engage with the wall and it is going to probably break or cause some chatter. So that's very important that there's enough space there between the two. So let's just finish this off, and you'll see that when it's finished doing its 3D finishing pass, that the two did not actually meet. Another thing I want to show you, and it's something that I really like about the Vectric software, is in your previews of the toolpaths, what you see is what you get, which means anything that you see that's incorrect in your preview is what's going to happen out at the CNC machine in the real material. And I should have picked up on this. I didn't look carefully enough and this caught me out. Now, I don't know if you guys can see this, but there's actually on the right hand side over here, and in this area here, I'm going to try to zoom in for you so you can see this, but can you see these little green marks? Now this is one of the reasons I like to do my toolpaths in different colors. Now if they were all the same color, you would never pick up on this, but as you can see here, the green from our previous roughing toolpath has not been cleaned up by this 3D finishing toolpath. And what has happened here is you can actually see the marks from the tool in the 3D toolpath. And this is exactly what I got when I cut out the part on the CNC machine. And what I should have done to prevent this, and I'm going to show you this now, is in the roughing toolpath, I should have actually set a machining allowance. So let's go and do that now and we'll see how this cleans up. So we'll go back to our let's undo that last change over here, or let's reset our preview actually. Let's go back to our roughing toolpath, and over here under machining allowance I should have set a slight allowance here. So I'm going to put in 0.5 mil, 0.5 millimeters. I'm going to calculate that, and if we preview that toolpath, you'll see it looks a little bit different. It's actually left this area alone. It hasn't colored it in green to show that it's been untouched by the tool. If we go now and we preview our 3D toolpath, you'll see that there's no green areas anymore. They've been removed just by allowing that slight machining allowance. So that's very important, and next time I will remember that because I learned the hard way. But the takeaway from this point is that before you cut something out on the actual machine, very carefully inspect the preview window here and look for anything that looks out of place, because guaranteed if it's out of place in the preview, it's going to be out of place on your final part. Okay, let's jump to the CNC machine and watch the parts actually being cut out, talk a little bit about tooling and the processes used. I apologize in advance, some of this video is a little bit shaky. It was filmed with my phone, and next time we'll have a proper tripod in place and some better quality video. First up, let's talk about tooling. These are the three tools that we used for the whole creation process. The first tool is this one over here, which is a 12.7mm bottom clearer. Because this is recycled wood, it was not perfectly flat. It came from an old antique chair, and this bit was used to flatten the one surface. The part was flipped and the other side was flattened as well, to a depth of I think I did 1 mil at a time. The fixturing of this piece of wood was done via screw holes and a countersink, so the screw head was below the surface on both sides. The second tool that we used is a 6 mil carbide end mill, and this was used for the roughing, the 3D roughing, and for the final profiling, cutting the part out. For all the other operations, the 1/8 inch ball nose carbide end mill was used. This was both for the 3D toolpath, or the final 3D toolpath, as well as carving the vector path on the surface.
Thanks.